Okay, let's continue with our quiz review covering the concepts of critical numbers, the intermediate value theorem, the mean value theorem, and the extreme value theorem. So here we have a question to determine whether that mean value theorem can be applied on the closed interval, and if the mean value theorem does apply, find all the values where it applies. All right. So we know that we need to have a differentiable function on the interval 0 to 2, on that open interval. Because if our function is differentiable on that open interval, then that means that I am going to be continuous. And if I have values at the endpoints, that means that I also have my closed interval 0 to 2. All right, so all of those things apply. So what does that tell us? That tells us that somewhere f prime of x is going to be equal to f of 2 minus f of 0 all over 2 minus 0. So in other words, somewhere the instantaneous rate of change is going to be equal to the average rate of change. Right? Well, what is f of 2? F of 2 is going to be 3 times 4, 12, minus 2, 10, plus 1. So that's 11. Then f of 0, 3 times 0 minus 0 plus 1, that's 1, all over 2, so that's going to give me 5. So therefore, somewhere f prime of x is going to be equal to 5. So in other words, we need to find f prime of x, right? Well, f prime of x is going to be equal to 6x minus 1. So we need to solve for some value c to be equal to 5, which means 6 times c minus 1 needs to equal 5. So therefore, c has to be equal to 1, and that's because 6c would need to be equal to 6. All right, now, if you use an x instead of a c, generally that is okay, but it technically does say find all values of c. Okay, then our next problem, find where the average rate of change equals the instantaneous rate of change for this function on this interval, right? So note that this is, once again, a mean value theorem because for our function, the square root, we know that on the closed interval 2 to 6, our function is continuous. And we know it's differentiable on the open interval. So we want to find f prime of x. F prime of x, right? Or in this case, y prime if we're going to maintain our notation. So y prime is going to be the derivative, which is going to be 1 over 2 square roots of x minus 2. Recall that the derivative with respect to x of the square root of u is equal to u prime over 2 square roots of u. The derivative of x minus 2 is 1, so there we have u prime over 2 square roots of u. And we need to figure out when that is going to equal the average rate of change. So when that's going to equal y of 6 minus y of 2 all over 6 minus 2. Well, y of 6 is the square root of 4, so that's 2. Y of 2 is the square root of 0, so that's 0. So then that's going to be 1/2. So we need to solve 1 over 2 square roots of x minus 2 is equal to 1/2. So therefore, we need to solve for the square root of x minus 2 being equal to 1. So our solution is when x is equal to 3. What did we do there? Well, notice that I have 1/2 and then I have x minus 2. But I just want the answer to be 1/2, which means the square root of x minus 2 needs to equal 1, which means I need to have the square root of 1. And the square root of 1 will be true if x is 3. Okay. Continuing with our work, Here we have a function that is differentiable on the open interval, and we have a closed endpoints to our interval, and we want to identify which of the following must be true. So if we're continuous, IVT applies, the intermediate value theorem. If we're continuous on a closed interval, extreme value theorem applies. If we're continuous on a closed interval and differentiable on the open interval, the mean value theorem applies. So, can we identify which theorem is being represented, then decide which must be true? So f has at least two zeros, so therefore f is equal to 0. So we're given f, asked about f, that's going to be an intermediate value theorem problem. Right? We talk about one horizontal tangent. That means f prime of 0. We're given f, right? We're talking about f, asking about f prime. That's a mean value theorem problem. If we're given f and we're asked about f, that's an intermediate value theorem problem. Now, does f have at least two zeros? Well, let's see. I go from -5 to +5. If I'm continuous, I have to go through 0. And then I go from +5 back to -5, so I have to go through the 0 twice. So we know that that is true. Because that is true, we know the answer is not none. And because that is true, we cannot eliminate anything else. Do we have at least one horizontal tangent? So in other words, do we have two endpoints with the same value? Well, notice f of -2 is -5, and f of 9 is -5. So therefore, the slope between those two endpoints is 0. So by the mean value theorem, because we are continuous on a closed interval and differentiable on the open interval, our mean value theorem guarantees that we will have the slope of the secant line equal to the instantaneous rate of change, or the slope of the tangent line. So that has to be true. So we are not 1 only, and we are not 1 and 3 only. So now we need to determine, is the IVT true for number 3? Well, here it says somewhere between 2 and 5, the function is equal to 3. Well, I go from -5 to 5. That means I go through 3. So this is also true. So E would be the correct answer for this problem. Okay? And if I'm not mistaken, that's it for us. Yes. There we have it. Some intermediate value theorem, some mean value theorem, some extreme value theorem. Make sure that you are working through your practice problems and being careful with your work. Ask questions as needed, and best of luck to you on your assessment as you demonstrate where your knowledge is at the current time. We always seek to improve. Please ask those questions.